Good morning. This is your stats sensei, Mr. Spensei, and this is going to be an exit ticket going over the normal distribution of means and z-scores. So, a survey is planned to determine the mean monthly electric bill for residents in a suburban city. The average electricity bill is 275 with a standard deviation of $50. It should have said that this is normal, so I'm going to go ahead and add that it's normal. Otherwise, we can't do this work. So it should have told us the underlying distribution is normal. Otherwise, it's not possible to do. And it says, what is a z-score associated with the bottom 4% of all electricity bills? Without it being normal, I can't do this. But they told me a percent. Well, as soon as they tell me it's a percent, I know that I'm working with an inverse norm. All right. And anytime they give me a percent and I'm working with an inverse norm, I put an X. Okay, well, that 4%, is that above the X or below it? Well, it says bottom, so that means it must be below it. And please remember, anytime you have a percent, divide it by 100. So I'm going to go ahead and draw a picture here. And we know our mean is, but we're working for a z-score. All z-scores have a mean of 0 and a standard deviation of 1, and we're looking for the bottom 4%. So 0.04, because that's what that 4 divided by 100 is. And we're looking for this z-score there. Well, when I go to the calculator, it goes second vars, inverse norm, and it asks for my area, and it asks for my mean, and it asks for my standard deviation. So my inverse norm, my area or percentage is 0.04. My mean is 0. My standard deviation is 1. This is the PMS. And if you notice, we shaded on the left-hand side. So I need to write the word left to remind myself that, hey, we use the left-hand side. And we'll see what happens. So 0.04, mean is 0, standard deviation of 1. Make sure we have left highlighted. And we end up with a z-score. Z equals negative 1.7506. And because we are below 0, it would make sense that our z-score is negative, so I feel pretty good about this. All right, what is the probability that a random sample of 50 residents has a mean? So we're asking for a sample of 50 of less than 260. So let's go ahead and draw a picture of this. Well, our mean was given as 275, so I'm going to go ahead and label that as 275. They say, oh, we want 260, so 260 is down here. Please remember, this goes to negative infinity, and I'm looking for that area right there. I'm looking for that percentage. All right, and this is a mean, so this is a x bar. So we're looking for the probability that x bar is less than 260. All right, because I'm working with a mean, and by the way, I'm going to go ahead and write all my information down. I know that this is going to be a z-test. And in this case, my mean was given as 275. And let's look at the calculator so it can remind us. Oops. Stat, test, z-test, press enter. Mean, 275. It also asked for our standard deviation. Well, they told us the standard deviation of the population was 50. And we have a sample size. Then it asked for X bar. And it told us our X bar was 260. We have a sample size of 50. And we want it to be less than, and we shade it to the left. So this will be our symbol. Now, while I don't require this, a lot of teachers will. So I'm going to write the formula and plug in. Technically, we're looking for this formula, z equals x bar minus mu standard deviation divided by the square root of n. So we want the probability that z is less than 260 minus the 275 over 50 divided by the square root of, oh, excuse me, is our sample size 52? Yep, our sample size is 50 as well. All right, so that's what we're looking for. So let's put our information in. Standard deviation was 50. X bar, 260. Sample size, 50. Make sure less than's highlighted and we press calculate. So we have a z-score of negative 2.12. So the probability that z is less than negative 2.1213 equals 0.0169. All right. Next one. What's the probability that a residence electricity bill exceeds 360? Well, remember, A is just one. And if it's just one, we're looking for a normal CDF. So this will be a normal CDF problem. Let's draw a picture. Once again, our mean is still 275. That's our mean. Our standard deviation is 50 from above. And we want to know the probability that it exceeds 360. So this goes all the way to positive infinity. When I go second vars, normal CDF, I put a lower bound of, lower part of my shading was 360, because we're looking for the probability that X is greater than 360. Now notice this is an X. The problem above was an X bar. This asks for a single residence, so it's just a single value. This asks for a mean, so it's X bar, because the mean is the average and X bar is the average. So lower bound, 360, upper bound, infinity, positive infinity. Mean was 275, and our standard deviation is 50. So let's put that in there, 360. Largest value in the calculator is 9 raised to the 99th. Mean of 275, standard deviation of 50. And we end up getting 0.0445. All right, there's the answer for that. Next one. 8% of all electricity values will be above what value? 8%. All right. The fact that I have a percentage tells me I'm working with an inverse norm. Anytime they have a percent, I draw an X, and this 8 is supposed to be above it. Please remember, we're going to divide that 8 by 100. So my picture looks like this. And this time they're looking for the actual values. Please remember, they gave us the mean equaling 275, and they gave me a standard deviation of the population of equal to 50. So my mean is 275, and we're looking for 8%, which is right here, 0.08. And not that it's important for this problem, but remember, it does go to positive infinity. All right, so when we go to the calculator, what does the calculator ask for? Well, it's going to ask us for a PMS, second vars, inverse norm, the area, that's our probability or our percentage, which is 0.08. Then it asks for our mean. Well, in this case, we're working with actual values. So we're not asking for z-scores, we're using actual values. So we have to use the actual mean, which is 275, and we have to use the actual standard deviation, was 50. So this is our PMS. And we need to also worry about the direction. In this case, we shaded on the right-hand side. We started shaded from the right and shading this way. So we need to make sure that we highlight the word right. And we also need to write the word right. And we'll see what our probability is. So not looking for a probability, we're looking for an actual value, and our actual value is 345.2535. So Actual value of $345.25 because we were looking for the X there. All right. The next one, 65% of all values are between what values? And this is going to be centered on the mean. It doesn't say that. We probably should address that, but we're meaning for it to be centered on the mean. So if I'm drawing a picture, this is going to be 275, and we want 65% to be in this shaded area, this 0.65. And this will be my lower value, and this will be my upper value. All right, so this will be my lower value and my upper value. Because they gave us a percentage, that lets me know it's an inverse norm. And this should have said centered on the mean. Centered on the mean. So inverse norm, and we're going to put 0.65. And our mean of the population was 275. Our standard deviation for the population was 50. That's our PMS. And we're going to go to the calculator real quickly because it's going to be a little bit different here. Second vars, inverse norm. And we're going to put in 0.65, mean of 275, standard deviation of 50. And we're going to choose the word center. And if we do everything correctly, it'll give us two values. It'll give us a lower bound and an upper bound. So $228.27 to an upper bound of 321.72. This is my lower bound. This is my upper bound. All right. Hope that helped. Thanks for watching. I look forward to seeing you on the next one. Thank you.